work on example 25. Okay, in this example, we are going to express the following numbers as product of prime numbers. What is a product means? The product is the result, answer, right? This is going to be the answer. So we have to show this as the product of prime numbers. What are the prime numbers that makes this as the answer? Okay, product means multiplies. Okay, multiplication, answer of a multiplication. These are the three problems. Solution 1. For A, 6. How do we write 6? 2 into 3, right? What is the other option for writing 6? 1 into 6. But in this case, neither 1 is a prime number nor 6 is a prime number. 6 is a composite number. Okay, therefore, it does not meet the requirement. We have to write it as a product of prime numbers only. Okay, what is the other options? If we divide 6 by 2, we get 3, right? So we found out 2 into 3 is a factor. 2 3s are 6. Here both 2 and 3 are prime numbers. Okay, so that is the answer. Now let us take the other question, B, 10. This question, what are the ways we find? 1 into 10 is one choice, but in this case, neither 1 nor 10 is a prime number. So, since both are not prime numbers, we cannot have this as the solution, right? So, what is the other choice? Other factors of 10 is 2 into 5 gives 10. 2 5s are 10. So, 10 is the product. So 2 and 5 are prime numbers. Since 2 and 5 are prime numbers, it satisfies this requirement. Let us take the third question, which is 12. So 1 into 12 is one such a thing, but neither 1 nor 12 are prime number. Therefore, this is not a choice. Other option is 2 6 are 12 or 3 4s are 12. Okay, if we take 3 4s, 3 is a prime number, we know, but 4 is a composite number. But we need to find it as a product of prime numbers, okay, which is called prime factorization. We are only finding the factors of prime numbers, right? How can we write the 4? We can split this 4 as 2 into 2, right? So 3 multiplied by 2 multiplied by 2. But 2, so 3 2s are 6, 6 2s are 12. We get the answer. But here 3 and 2 are prime numbers, right? Look, all the 3 are prime numbers. Since therefore 3 and 2 are prime numbers, we got this is 12 can be written like this, right? It's a product of 3 into 2 into 2. Therefore, we got the answer. The prime factors are 3 into 2 into 2. Here all the composite numbers are expressed as product of prime numbers. That is, 4 is a composite number. We expressed or we converted that 4 as product of prime numbers. We converted it as 2 into 2, which is both are prime numbers, right? This is called prime factorization. What is prime factorization? Converting all the numbers, factors to prime numbers. Here naturally these two are prime numbers, but we converted this composite number also as a prime number. This is called prime factorization. Thus, many composite number can be written as product of prime numbers like 8, 12, all these are composite numbers. These can be written as prime numbers as well. Okay. This is what the Greek mathematician Eratosthenes suggested, a simple method, that is striking off method, right? So 1 is not a prime, 2 is not. That's what we saw in the previous video. The way he strike off and circled the numbers, if we take between 1 and 100, this is what is left out. If if you see, this is what is left out from number 1 till 100. Okay, this observation what we found, these are all the prime numbers left out. Okay, all the prime numbers are odd numbers except the number 2. This is what we observed. Second thing we observed, only 5 is a prime number. The rest are multiples of 5. None other numbers end with 5. There is no other prime number ending with 5. And there are 25 prime numbers between 1 and 100. These are the 3 observations. Okay. List all the prime numbers between 20 and 30. This is part of example 26. How to find the solution? The numbers between 20 and 30. We will do the sieve method. Okay, what is sieve method? The Greek mathematician method, right? We just write down all the numbers between 20 to 30. 22 and 2, 22 to 34, 28 to 9, right? Then we see, first we take 21. Is it a even number? No, it's an odd number. Does it have more than 2 divisors? Yes, 1, 21, 3 also divides it 7 times. So this is not a prime number. 22 is an even number, not a prime number. 23 is an odd number. Does it have more than 1 divisor, 2 divisors? No. If you have, remember one, tell me. So this is a prime number. 24 is an even number, therefore not a prime number. 25, obvious, 5 goes with it. There is one, but for 5, no other number ends with 5 in prime numbers. 26 is an even number, not a prime number. 27 is an odd number. Does it have any other number more than 2 divisors? Yes. 7 divided by 3 is 9. So it is not a prime number. 28 even number, therefore not a prime number. Finally, 29 is left out. There is no other number that divides more than 2 divisors. It has only 2 divisors, 1 and 29. Therefore, it is a prime number. Therefore, we found the prime numbers are 23 and 29. Solve this exercise. Write all the divisors of and factors of these numbers given below. 16, 25, 27, 42, etc. Okay. Find the prime factorization of the following numbers: 36, 24, 80, 63, 120. Hope you remember we did prime factorization. Right? How many numbers have exactly 2 divisors from 30 to 40? List all the numbers and use the sieve method to cancel out. Okay. List all the primes between 1 and 20, 45 and 50, 55 and 65, 90 and 100. Okay. List all the numbers and find it out. Okay. Here finally these the things to remember. Summary from this chapter. What all we saw: a number which divides a given number leaving no remainder is called a divisor of the given number. Right? We saw that, right? 4 by 2. Then 2 is a divisor because no remainder left. Point 2. Some numbers have only 2 divisors, that is 1 and the number itself. For the number 3, we saw there is only 1 and the 3. There is no other divisor. Okay. Likewise, the divisors of a number other than 1 and the number itself are called the factors of that number. For example, for a number 4, 1, 2 and 4 are divisors. But 2 is a factor as per this point. Point 4, the whole numbers which are multiples of 2 are called even numbers. Which are multiples of 2 are called even numbers. Okay. 2, 4, 6, 8 and 12, etc. The whole numbers which are not multiples of 2 are called odd numbers. What are they? 1, 3, 5, 6, 7, etc. 1, 3, 5, 7, 9, like that. Okay. Point 6, the natural numbers which have only 2 divisors are called prime numbers. What are prime numbers? The natural numbers which have only 2 divisors. More than 2 divisors are called composite numbers. Finally, the composite number can be written as a product of prime numbers. This is called prime factorization. Okay. With that, we have completed this prime numbers.